Hey everyone, you ever stop and wonder how your phone just connects to the internet? Like instantly? Today, we're going to pull back the curtain on computer networks. They're kind of like this invisible force that powers pretty much our entire digital world. So let's dive in and see how it all really works.
I mean, really think about it for a second. You can send a photo to a friend who's miles away, and they get it in like a second. Or you can video call them, and it's almost perfectly in sync. How is that even possible? Well, the answer, in a single word, is networks.
Okay, so to really get a handle on all this incredible tech, we've got to start with the absolute basics. First question, what exactly is a computer network?
When you boil it all down, it's actually super simple. A network is just a bunch of devices connected together. We're talking two or more devices, like your computer, your phone, maybe a tablet. And why connect them? The entire reason is so they can share stuff. Things like data, messages, or even resources like a printer.
Now, these connections really come in two main types. First, you've got your wired networks. These use actual physical cables, like that Ethernet cord you might plug into your computer for a super stable connection. And then there's the one we're all using constantly, wireless. This is your Wi-Fi, your Bluetooth connecting your headphones, no wires needed.
So, okay, we know what a network is, but why should you care? Why does it matter so much? Well, let's take a look at how these networks are literally powering our everyday lives.
Honestly, networks are the backbone of everything we do online. For communication, it's how we send emails or hop on a video call. For school, it's absolutely essential for things like online classes or sharing study materials. And even at home, that smart speaker you talk to, that's all running on your home network.
All right, now let's zoom in on a really special kind of network, one that most of us carry around in our pockets. Let's talk about mobile networks. This is the magic that lets us take the internet with us, wherever we go.
If you look at how these networks have changed over time, the goal has always been surprisingly simple. As we've gone from 4G to 5G and whatever comes next, the mission is always the same. Just make the internet faster and make it more reliable for all of us.
So you've probably seen that little 4G or LTE icon at the top of your phone screen a million times. Let's actually break down what that means, because this is the technology that truly made our modern mobile internet a reality. Okay, here's a really key point, especially if you've got exams coming up. LTE stands for long-term evolution. The best way to think about it is just as a huge upgrade that gave 4G networks a massive speed boost.
And that speed, well, that's what lets us do all the things we just take for granted on our phones today. Thanks to 4G LTE, we can have smooth video calls, we can actually attend an online class without constant buffering, and we can download big files pretty darn fast.
But technology never just sits still, right? It's always moving forward. So what comes after 4G? Let's talk about the incredible power of 5G.
Now, 5G isn't just a tiny step up. It is a giant leap. It makes four key things way better: speed, something called latency, capacity, and reliability. Let's break down each one of those real quick.
First up, speed. And we are talking mind-blowingly fast. With 5G, you could theoretically download a full movie in just a few seconds. It's a total game changer.
Next is latency. Now, this is a really important term. Latency is just a fancy word for delay. You know that tiny lag when you click on something online? With 5G, that delay is almost completely gone. It's practically instant.
Okay, third advantage, capacity. Have you ever been to a concert or a big sports game and your internet just crawls? That's because the 4G network is getting overwhelmed. 5G is built to handle tons and tons of devices all at once, in the same place, without slowing down for anyone.
And finally, we have reliability. This one's simple. It just means your 5G connection is going to be super strong and stable. Think fewer dropped calls, way less buffering, just a solid connection you can actually count on.
Whew. Okay, that was a lot of information. So let's just do a super quick recap of the most important things you need to remember. This is the stuff you'll definitely want to know for any exams. All right, let's run through it. Number one, a network. It's just two or more devices connected so they can share things. Easy enough. Number two, 4G LTE. That's our current standard, giving us fast speeds for stuff like video calls. And number three, 5G. That's the next big thing. Think instant speed, almost zero delay, and it can handle huge crowds.
And there you have it. So I want to leave you with a question to think about.
Now that you know what 5G can do, with its incredible speed and that near-instant connection, what kind of amazing new things do you think it's going to make possible? I mean, are we talking about self-driving cars that all talk to each other? Or virtual reality that feels totally real? The future's wide open. Thanks so much for watching. Hey everyone, so today we're going to dive into the concept of telecommunication. I know, it sounds like a really technical term, but honestly, it's something you use constantly every single day. Let's break down what it really is.
I mean, have you ever really thought about it? You hit send on a message and poof, in just a few seconds it can pop up on a friend's phone halfway across the world. How on earth does that happen? Well, it's all thanks to the magic of telecommunication, and today we're going to pull back the curtain and see how it all works.
So here's what we've got lined up. We'll start with how this stuff fits into your daily life. Then we'll lock down the definition you need for your exams. After that, we'll look at how everything connects, what we're actually sharing, and then wrap up with a quick study session to get you totally prepared.
All right, first up, a world in your pocket. Before we get into all the official definitions, let's just talk about your everyday life. The main thing to get is that you're already an expert user of this technology, even if you don't call it telecommunication. Just look at these examples. Making a phone call, sending a message, even kicking back and watching TV. Yep, those are all telecommunication. Every time you do one of these things, you're tapping into this massive worldwide system of sending and receiving information. You're doing it all the time.
Okay, let's get to the part your exam is really going to care about. We're going to nail down the official definition and figure out what this word truly means. This part is super important, so let's focus in.
I love this slide because it makes it so simple. Think of telecommunication like a recipe with 3 key ingredients. First, you need information. That's your voice, a text, a picture, or whatever. Second, it has to cover long distances. We're not just shouting across the room here. And third, you need electronic devices, like your phone or a laptop to do the sending and receiving. And here it is, the core definition you need to burn into your brain. Telecommunication is the sending and receiving of information over long distances using electronic devices. This sentence is pure gold for your exam, so make sure you know it inside and out. So, we know what it is, but how does it all happen? I mean, how does your phone talk to a server in another country? Let's take a look at the system that makes all this magic possible.
The secret to all of this is the network. A network is really just a bunch of devices. Phones, computers, servers, you name it, all connected so they can share stuff. Think of it like a group of friends who can all text and call each other instantly. Now, these devices can connect in 2 main ways. You've got your wired connections. Those are physical cables, like the ones buried under the street. And then you have wireless connections, which send information through the air as invisible waves. That's your Wi-Fi and your phone's data signal. This map right here shows the whole shebang. Let's follow a message, okay? It starts with you on your phone. That message, or outgoing traffic, zips over to a nearby cell tower. From there, it jumps onto the internet, which is basically a giant network of networks. It might even bounce off a satellite way up in space before it finally lands as incoming traffic on your friend's computer. It's this incredible connected web, and every part has a job to do. Okay, we get the system, but what are we actually sending through all these wires and waves? Well, let's talk about the different kinds of information we share all day long. Pretty much anything that can be turned into digital data. We send simple text messages, we share our voices on calls, we snap and send photos, and we stream whole movies. All these different types of data get packaged up and shot through the network, arriving on the other side almost instantly. It's pretty amazing when you think about it. All right, let's switch gears. We've learned the ideas, now let's make sure you get those top marks. Welcome to your exam quick study section. Everything from this point on is laser focused on helping you ace those questions. When it comes to your exam, it really boils down to these 3 key terms: telecommunication, network, and wireless. You have got to know what these mean. They're the building blocks for this whole chapter, so please make sure you've got them memorized.
So, what kind of questions should you expect? You can pretty much bet you'll be asked to define telecommunication or network. A classic question is to ask you to tell the difference between wired and wireless, and they might even ask you to explain the flow of information, maybe by drawing a simple diagram, just like the one we looked at. So be ready for those.
Now, let's talk about how to avoid losing easy marks. First big one, when you define telecommunication, don't forget to say long distances. It's super important. Second, remember the internet is a huge, specific network, but not every little network is the internet. And last, wireless isn't magic. It still needs real, physical stuff like towers and satellites to work.
And hey, to make this even easier, here's a little memory trick for you. To remember the core of that main definition, just think of the name TED. Telecommunication uses electronic devices. It's a super simple way to make sure you never forget that basic idea. And there you have it. That's the concept of telecommunication. We've defined it, we've looked at the networks that make it run, and we've covered the key stuff for your exam. So I'll leave you with this one question to think about. We've built this incredible system to connect the world. Now that you know the basics of how it works, what do you think is coming next?
Hey everyone! Today, we're going to dive into something that affects all of us, every single day, internet speed. We're going to break down everything you need to know about broadband technology, especially what you'll need for your upcoming exams. So, let's get right into it. So let me ask you a question. Have you ever been in the middle of, say, an intense online game, or maybe you're watching the best part of a movie and bam, it just freezes? You get that spinning circle, that dreaded buffering screen. Ugh! It's the worst, right? Well, that exact frustration is what we're talking about today. I mean, think about it. Everything we love doing online, streaming videos, jumping into our online classes, gaming with our friends, downloading big files, it all needs a fast and stable internet connection. Without one, we're just stuck staring at that screen, waiting. So what is the fix for all that endless buffering and those painfully slow downloads? Well, the answer is a word I'm sure you've heard a million times: broadband. But let's actually break down what that really means. Okay, this is a big one for your exams, so listen up. Here's the definition. Broadband is a high-speed internet connection. The key idea here is its capacity. It's all about being able to send and receive huge amounts of data and do it fast. That's really the main thing you got to remember. To really wrap your head around just how fast broadband is, let's throw it back and compare it to the old way of getting online, called dial-up. Think of it like this. Dial-up is the tortoise, just slowly plugging along. Broadband, that's the rocket ship. It's a massive, massive leap in technology that took us from ridiculously slow to super fast. All right, so how does this super fast internet actually make its way to us? Well, there are two main ways. First up, we're going to look at wired connections. And just like the name says, this means there's an actual physical wire or cable that runs right to your home or school. First on our list is DSL. That stands for Digital Subscriber Line. Now, the most important thing to remember about DSL is that it uses the telephone lines that are probably already in your house. It was a really clever way to get faster internet to people without needing to install a bunch of brand new wires. Next, we've got cable internet, and it's a similar idea to DSL. Instead of phone lines, cable internet uses the very same coaxial cables that bring you your cable TV. So it kind of piggybacks on the TV network to bring high-speed internet into your home. And now, for the undisputed champion of speed, fiber optic. This stuff is a total game changer. It works by sending data as little pulses of light through tiny strands of glass that are as thin as a human hair. And, since we know nothing travels faster than light, fiber optic gives us the fastest internet speeds on the planet. This is the tech that's going to power the future, stuff like virtual reality and cloud gaming. For sure, remember this term for your exams. Okay, so we've covered the physical wires, but what happens if you can't run a cable to a house? Well, that brings us to our next big category, wireless connections. This is where the internet literally travels through the air to get to you. First up in the wireless world is satellite internet. So a dish at your house sends a signal way up to a satellite orbiting the Earth, and that satellite beams the internet back down. It's an absolutely essential technology for people who live in rural or remote areas where it's just not practical to lay down cables. And finally, we have the wireless tech that you and I use every single day. Mobile wireless. This is your 4G or 5G on your smartphone. It's the Wi-Fi you connect to at home or in your school. It all works by sending radio waves between your phone or laptop and a nearby cell tower or your router. So when you look around, where do you find all this tech? The short answer is everywhere. Broadband is what powers our homes, our schools, our offices, and even public spots like coffee shops and libraries. It's really become a basic part of how we live our lives. Okay, everybody, let's switch gears and get into exam mode. I really want you to focus on these next couple of slides because this is your guide to crushing any questions you get about broadband. We're going to boil it all down to the most important points. This slide right here is perfect for studying. On the left, you've got the goal, basically getting fast internet so we can do things like watch videos and join our classes without waiting. And on the right, you've got the tech. Those 5 ways to get it that we just talked about: DSL, cable, fiber, satellite, and wireless. Seriously, this table is your best friend for revision. All right, let's do a quick fire recap of those 5 key types one more time. We've got DSL, which uses phone lines; cable, which uses TV wires; fiber optic, that's the super fast one with glass and light; satellite, which connects from space; and wireless, which is our 4G and Wi-Fi. A really common exam question is just to list and describe these, so make sure you've got them down. And that's a wrap. But before you go, to make sure it all sunk in, I've got one final challenge question for you. What do we call that super fast technology that sends internet through special glass wires using pulses of light? Think about it. Got it? If you said fiber optic, you are 100% correct. Definitely keep that one in mind. Thanks so much for watching, and good luck with your studies.
Hey everyone, and welcome. Today, we're going to tackle a term that you hear all the time, but might not really get: network throughput. Seriously, if you've ever paid for fast internet, but still felt like things were slow, you're in the right place. We're about to find out why. Let's jump in.
You know what I'm talking about, right? That little spanning circle. The circle of doom. You're right at the best part of a movie, or you're about to win an online game, and bam! Everything just stops. It's got to be one of the most frustrating things ever. So what is actually happening there?
Well, the secret answer to that annoying buffering wheel is a little thing called throughput. And here's the deal. It has nothing to do with the speed your internet company advertises on TV. This is all about the speed you actually get. So let's pull back the curtain and see what's really going on. Okay, I want you to burn this word into your brain: actual. Throughput isn't the theoretical, maybe on a good day speed of your connection. No way. It's the real, measurable amount of data that successfully gets from point A to point B in a given amount of time. It's reality versus the advertisement. It's the truth.
Here's the best way to think about it. Imagine your internet connection is a big highway. Now, bandwidth is how many lanes the highway has. Maybe it's a huge 8-lane superhighway. But throughput is how many cars actually make it to the next city in 1 hour. Because, even with 8 lanes, you could have a traffic jam, right? Or construction. Throughput is the real flow of traffic, not just the size of the road.
Okay, so if throughput is the real speed, how do we measure it? What are the units? Just like we measure distance in miles or kilometers, we have special units to measure how fast data is moving.
It all starts with the tiniest piece of data, a single bit. So our base unit is BPS, or bits per second. But honestly, modern internet is way too fast for that. So we usually talk about Mbps. That's megabits per second. 1 million bits flying through your internet connection every single second. This is probably what your plan at home is measured in. And then for the really high-speed stuff, we've got GBps, gigabits per second. That's a mind-boggling 1 billion bits every second. Whoa.
So yeah, just think of it as a ladder of speed. At the very bottom, you have bits. You take a big step up to megabits, which is where most of us live our daily online lives. And then you leap to the very top with gigabits for those super powerful networks. Remember those 3: bits, megabits, and gigabits. They're the key to understanding this whole thing.
So we've got the definition, we've got the unit, but why should you care? What's the point? Let's get to the good stuff, why this matters to you. And the simple answer is, your throughput affects literally everything you do online.
When you have high throughput, life is just better. Downloads that used to take an hour are done in minutes. You can stream 4K movies with 0 buffering. Your online games are perfectly smooth, no lag. You get the picture. High throughput just means a faster, smoother, way less frustrating time online.
It all boils down to this, really. Whether you're downloading a huge game, watching your favorite show, or just clicking around on websites, everything happens faster. It's not just about speed. It's about having a smooth, stress-free online life.
Okay, pencils up. Let's shift gears for a minute. I know you've got exams, so let's lock in on exactly what you need to know to ace this topic. Think of this as your personal study guide.
So, let's play teacher for a second. Imagine the exam question is, define throughput. What's the one word, the single most important word that has to be in your answer?
This right here. This is the definition you need to memorize. Throughput is the actual amount of data that is successfully sent or received. That word actual is the money word. It's what separates it from bandwidth. If you forget everything else, just remember that one word, actual.
All right, exam question alert. This is a super common one. A short answer question that just says, list 2 benefits of high network throughput. What would you write down? It's easy. You could just write quicker downloads and video streaming without buffering. Boom. Perfect answers. They're short, they're to the point, and they show you get it. That's easy marks right there.
And hey, if you need a little trick to remember this for the test, here's a good one. Just think, throughput tells you the truth. It's not the advertised speed, it's the true speed, the truth about what's actually going on with your connection.
So let's wrap this all up in a nutshell. We hit 3 main things. First, the definition. It's the actual rate data gets through successfully. Second, the units. We measure it in BPS, Mbps, and Gbps. And third, the result. The higher the throughput, the happier you are online. That's pretty much everything you need to know.
And that's a wrap on throughput. So I'll leave you with this final thought. Now that you know the difference between the advertised speed and the real speed, how are you going to think about your own internet connection? Maybe next time you see that spinning wheel, you'll know exactly what's happening behind the scenes. Thanks for tuning in.
All right, today we're going to break down a word you hear all the time, bandwidth. Think of this as your guide to understanding why your internet works, or sometimes why it doesn't. So let's jump right in. You know that feeling, right? You're about to watch the best part of a movie, or you're trying to log into an online class, and there it is, the spinning circle of doom. Ugh, it's the worst. And believe it or not, the reason behind all that frustration usually boils down to just one single thing. And that one thing is bandwidth. Now, getting a handle on this is super important, not just for your exams, but for, actually figuring out why your internet acts the way it does. So, what even is it? Okay, let's get right to the main definition. Bandwidth is the maximum amount of data that can travel through a network connection at one time. The most important words to remember here are maximum amount. That's the whole game right there. It's all about capacity. And this is where a lot of people get tripped up. They think bandwidth is the same thing as speed, but it's not. Really, it's about capacity. A good way to think about it is like a pipe. Bandwidth isn't how fast the water is moving, it's how wide the pipe is. To make that idea super clear, let's use an analogy that's perfect for this. I want you to picture your internet connection as a giant highway. And look at this, it shows it perfectly. See, low bandwidth is like a tiny 1-lane country road. Not many cars can fit, right? So you get a traffic jam. That's your buffering. But high bandwidth, that's a huge 8-lane superhighway. Tons of cars, or data, can just cruise through all at the same time, no problem. So it all comes down to this simple idea. Bandwidth is all about how much data can move at the same time. Just like a bigger highway lets more cars drive on it, higher bandwidth lets more data travel on it. It's really that straightforward. All right, so we've got this data highway idea down, but how do we actually measure the size of it? Well, for that, we need to talk about units. This is another one of those things you'll definitely need to know for your exams. So everything starts with the smallest unit, which is bits per second, or BPS. Think of that as one single car on our highway. But we usually deal with way more data than that, so the numbers get bigger. We go from kilobits to megabits, and then for really fast internet, we're talking gigabits per second, or Gbps. And I bet you've seen one of these before. The most common one you'll run into is Mbps, which stands for megabits per second. If you've ever checked out an internet plan for your house or your phone, that's the number they're always talking about. Okay, so we know what it is, and we know how to measure it. But so what? Why should you actually care about having a wider data highway? What does it do for you? Well, this little chart here makes it super clear. When you have higher bandwidth, that means you have more capacity, and more capacity lets more data get through at once. And that is what feels like fast internet to us. It's a straight line from one to the other. And here's what that actually means for you. More bandwidth means you can binge watch your favorite shows without it stopping to buffer every 5 seconds. It means you can download that huge game update or your school project in just a few minutes, not a few hours. And yeah, it means you can actually get through an online class without your screen freezing up. Okay, that was a lot to take in. So let's boil it all down to a super simple summary. Think of this next part as your ultimate cheat sheet to ace this topic on an exam. There are just 3 things you absolutely have to remember. Number 1, the definition. Bandwidth equals maximum capacity. Got it? Number 2, the units. It's measured in bits per second, all the way up to gigabits per second. And number 3, the analogy. Just remember the highway. Wider road, more data, less traffic. Easy. And what do you get when you put all that together? The result is exactly what we were talking about at the start. No more buffering, downloads that are actually fast, and just a way, way better time online. So to wrap this all up, I'll leave you with a little question to chew on. We've figured out that bandwidth is about the size of the data highway. But what about the actual speed it takes for one single car to get from point A to point B? That's a little something called latency, but that's a topic for another day. For now, great job and keep thinking. You know that phone in your pocket, the one you probably can't imagine living without. Ever wonder what made it so, well, smart? Today, we're going to dive into the one piece of tech that really started it all, 3G. This is what turned our phones from just making calls into the amazing little computers we use every single day. Seriously, just try to picture it for a second. No scrolling through TikTok on the bus. No FaceTiming your friends after school. No streaming your favorite music whenever you want. It sounds like a totally different world, right? Well, that was the reality for everyone before the technology we're about to explore. So to really get how everything changed, we've got to start with the basics. What in the world is 3G? Okay, so before 3G, there was 2G. And with 2G, you could make calls and send texts, sure. But trying to use the internet? Oh man, it felt like you were trying to wade through super thick mud. It was just painfully slow. Then 3G came along and completely changed the game. It was a massive leap forward that finally made the internet on your phone fast enough to actually, use. So here's the key definition you need to lock in your brain for your exams. 3G simply stands for third generation network. And that's exactly what it was. A huge, huge upgrade that made the internet on our phones way faster and so much easier to use. If you remember one thing, make it that. So we've established that 3G made the internet faster. Great. But so what? What did all that extra speed actually let us do? Well, this is where things get really exciting. This is where the magic really happened. Suddenly, you could browse actual websites on your phone without waiting forever. You could send and receive photos, and even short videos, which was a massive deal back then. And for the very first time, video calls were possible. You could actually see the person you were talking to. All of this opened the door for the first real mobile games and apps, which, as we all know, would go on to change everything. All right, let's recap these 4, because this is a classic exam topic. If a question asks about the main features of 3G, these are your 4 pillars. We've got faster internet browsing, multimedia messaging, that's sending pictures and videos, making video calls, and mobile broadband, which let us play online games and use apps. These were basically the building blocks for the smartphone in your hand right now. But these features were way more than just cool new tricks. They fundamentally changed our daily lives and how we all connect with each other. This is the moment, right here, that the mobile phone truly became a smartphone. It went from just a calling device to a powerful tool for learning. You could look up information anywhere. It became a hub for communication, connecting us through the first social media apps. And of course, it became an amazing entertainment device, with music, videos, and games right at our fingertips. And really, when you boil it all down, this is what it led to. By letting us share our lives with pictures and see each other's faces from across the globe, 3G technology genuinely made the world feel a little smaller and a whole lot more connected. Okay, let's switch gears a bit and get into revision mode. This last part is all about making sure you can remember these key ideas for your exams. Here's a super quick summary. Just remember these 4 things. First, evolution. It was a huge step up from 2G. Second, speed. It made mobile internet faster and much easier to use. Third, features. This gave us video calls, picture messaging, and apps. And finally, the result. It connected the world by making our smartphones, well, smart. Now, just imagine you see this question on your test paper. What were the many results of 3G technology? Take a moment to think. How would you even structure that answer? Well, don't worry because I've got a really neat trick for you. Here it is, a super simple way to remember the main results of 3G. Just think of the word fast. F is for the new features it gave us, like video calls and sending pictures. A is for the apps and games that became possible. S is for the speedy internet that powered everything. And T is for how it completely transformed our phones into the powerful devices we use today. Fast. A pretty easy way to remember it, right? So if there's one single thing you take away from all of this, it's that 3G was the big turning point. It's what made our phones smarter, more useful, and honestly, way more central to our lives, connecting us in ways that were totally impossible before. We've seen how 3G totally reshaped our world, and it kind of makes you wonder, what's going to be the next big leap in technology? What will it change about how we live, how we work, and how we connect with each other? Definitely something to think about. Thanks for joining me for this explainer. Hey everyone, so today we are going to dive into a piece of tech that you literally use every single day, 4G. We're going to break down what it is, how it works, and most importantly, the key things you absolutely need to know for your exams. Let's get right into it. You know that feeling, right? You're on a super important video call and boom, it freezes. Or you're trying to watch a video and all you see is that spinning, loading circle of doom. That right there, that frustration is exactly why we need to talk about the technology that swooped in to save the day. And that hero in our story is 4G. So let's start with the absolute basics. What exactly is it? Well, 4G simply stands for the fourth generation mobile network. It came right after the older, much slower 3G network. And its main mission? To make the internet on your phone way smoother and a whole lot quicker. And I'm not talking about a small update here. This was a massive leap forward, totally designed to change how we use our phones. To really get why 4G was such a big deal, you have to see what it was up against. So let's take a look at the massive upgrade it was, 3G versus 4G. The easiest way to think about it is like this. 3G was kind of like a snail, slow, plodding along, and honestly, not very reliable. And then 4G showed up, and it was like a rocket, insanely fast and super powerful. It's a really simple comparison to remember for your exams. Snail versus rocket. No contest, right? So, to just boil it down, 3G meant painfully slow speeds and that constant buffering we all hated. But 4G? It brought the speed and reliability that finally made the mobile internet truly useful for, well, everything we do with it today. So, we know 4G is fast, but what exactly gives it these superpowers? Let's dive into its key features. And you'll want to pay close attention here, because these are the details that often pop up in exam questions. First up, and it's probably the most famous feature of them all, is its incredible speed. Now, when we talk about speed, it's not just one thing. It's actually a two-way street. 4G delivered super fast download speeds, which is great for stuff like streaming movies, but it also gave us really fast upload speeds for things like posting your photos and videos. This powerful combo meant we got almost instant access to all our apps and websites. All right, on to our second key feature. Now listen up, because this is a really important one, especially for your exams. Low latency. So, what on earth is latency? This is a key definition. You should definitely jot this down. Latency is basically the delay, or what gamers call lag, between you doing something, like clicking a link, and seeing the result, like the website actually loading on your screen. It's that tiny, sometimes super frustrating pause. And this is where 4G really shines. It has very low latency, which means that tiny delay between your click and the result is almost non-existent. And the benefit? It makes everything you do online feel so much more responsive, almost instant. And what's the perfect example of why this is so important? Online gaming. Low latency is a total game changer, literally. You know that annoying lag that gets you defeated in a match? That's high latency. 4G's low latency meant you could finally have a smooth, competitive gaming experience right on your phone. It was a massive level up for mobile gamers. Okay, let's move on to our next key feature. And this one completely changed how we watch videos on the move: streaming quality. Before 4G, trying to watch a high-quality video on your phone was, well, it was a painful experience. But 4G had the speed and the reliability to finally make HD streaming on mobile a reality. And the best part? We finally said goodbye to that dreaded buffering wheel. We could watch crisp, clear videos without any annoying interruptions. So we've gone through the techie stuff: speed, low latency, and streaming quality. Now let's bring it all together and see how 4G actually fits into your everyday life. Think about it. For your schoolwork, 4G gives you instant access to online research and all your cloud documents. For fun, it means smooth gaming and watching HD movies wherever you are. And for staying in touch, it means lag-free video calls with your friends and family. It's simple, really. 4G just made the internet on our phones work seamlessly. All right, we've covered a lot of ground. So let's wrap this up with a quick summary and some key revision points to make sure you're all set for your exams. This mind map is a perfect revision tool because it ties everything together. You can see really clearly how 4G's main benefits, its speed, its great performance from low latency, and better media, all come from being a huge upgrade over 3G. Feel free to pause the screen here and just take it all in. Okay, for everyone making notes, these are the absolute must-know points. Number 1, 4G was the massive upgrade from 3G. 2, its key features are high speed and low latency. 3, remember, low latency means less lag, and that's absolutely crucial for gaming. And finally, 4, 4G is what made reliable HD video streaming possible on our phones. These are your golden nuggets for the exam. Look, if your brain is totally full and you can only remember one single thing from this whole explainer, let it be this. 4G changed mobile internet from just being usable to being fast and reliable. It took the internet on our phones from something that kind of worked to something we can truly depend on for everything. And that's a wrap. 4G really did lay the foundation for the mobile world we live in today. But now, with 5G slowly taking over, here's a little something to think about. What do you think will be the next big change in how we use our phones every day? Thanks for watching, and good luck with your studies.
You know that feeling, right? You're watching the most exciting part of a movie, or maybe you're in a crucial moment in a game, and then, bam! It freezes. You're just stuck staring at that dreaded buffering circle, spinning and spinning. It is the absolute worst.
Well, that frustrating little circle? It's basically a sign that our current technology is struggling to keep up with what we want to do. But what if I told you there's something coming that promises to make buffering a thing of the past? Well, that solution is 5G. And today, we are going to break down exactly what it is and, more importantly, why it matters for you, your exams, and pretty much your entire future.
So, let's just dive right in. We hear this term 5G thrown around all the time, but what does it actually mean? Let's get a really simple definition that you can use for your exams.
Honestly, the main idea is pretty simple. The G in 5G, it just stands for generation. I mean, think about it. We had 1G, which let us make basic phone calls. Then 2G came along and gave us texting. 3G gave us our first taste of the internet on our phones. And 4G is what most of us use right now for streaming videos and everything else. So 5G is just the next step in that line. It is the 5th generation mobile network. And that's a key definition to lock in your brain. It's the newest, latest standard for how we connect to the world.
Okay, so if 5G is just the next step, you might be thinking, is it really that big of a deal? And the answer is, oh yeah. It's not a small step. It's a massive, massive leap forward. So let's look at exactly what makes this upgrade so important.
So what's the big difference here? Well, compared to the 4G we use every day, 5G is better in 3 really key ways. First, it's way faster. We're talking seriously high download speeds. Second, it's smarter, because it uses the network way more efficiently. And third, it's just more powerful, with a ton more capability. If you remember anything from this, remember these 3 words: faster, smarter, and powerful.
This picture right here makes the difference crystal clear. You know, if 4G is like a steady tortoise, it gets the job done, eventually, then 5G is a full-on rocket ship. The jump in performance is just that dramatic. We're not just talking about being a little bit quicker, we are entering a whole new league of speed and power.
So what is it that gives 5G all that rocket fuel? What makes it so much better? Well, it all comes down to 3 core capabilities, which I kind of like to think of as its superpowers.
And here they are, our 3 superpowers: very high speed, a really strong connection, and the ability to support a ton of devices all at the same time. Now let's break down what each one of these actually means for us.
First up, very high speed. This is the one you'll notice the most. Right now with 4G, downloading a full movie might take you a few minutes. With 5G, we're talking about a few seconds. That's it. This kind of speed completely changes the game for entertainment, for online gaming, and for downloading any kind of large file.
Okay, superpower number 2 is a strong connection. Now, this isn't just about having fewer dropped calls. This is about something called latency. And latency is just a fancy technical word for delay. See, 5G has almost zero latency, which means there's practically no lag time between when you do something and when it happens. And you can imagine, that instant response is absolutely crucial for things that need to happen in real time.
And finally, superpower number 3, it supports a massive number of devices. Have you ever been somewhere super crowded, like a stadium or a concert, and suddenly your internet just stops working? Yeah, that's because the 4G network is totally overloaded. 5G, on the other hand, is built to handle millions of devices in a small area, all connected at once, without even breaking a sweat.
All right, so we've got these incredible superpowers: speed, reliability, and capacity. But what do they actually do for us in the real world? Let's check out some mind-blowing examples of how 5G is going to change pretty much everything.
Let's start with entertainment. That super fast speed finally makes things like virtual reality and augmented reality work the way they're supposed to. I mean, for VR to feel real, you can't have any lag or buffering. 5G speed gives you that perfectly smooth, immersive experience that makes you feel like you're really there. And here's where that second superpower, the strong, low-latency connection, becomes a matter of life and death. For a self-driving car to work properly, it has to react instantly. Just look at the flow here. The car sees an obstacle, it sends the data, and it reacts in a tiny fraction of a second. That near-zero delay is exactly what makes self-driving cars possible and, more importantly, safe.
And this is where that third superpower really shines. 5G is what makes the Internet of Things, or IoT, a reality on a massive scale. And IoT is just the idea of connecting all of our smart devices, not just our phones, but our homes, our cars, our watches, even our entire cities. 5G's ability to handle millions of devices lets everything talk to everything else, creating a truly connected world.
Okay, I know that was a lot of information, so let's pull it all together. This final section is basically your exam cheat sheet. It's designed to give you everything you need to know in one simple place, so pay close attention.
You can bet you're going to see questions just like these on your test. What is 5G? What are its main features? Or give some examples of how it's used. So let's make sure you've got the perfect answers ready to go.
All right, here it is, everything you need. Let's run through it real quick. For what is 5G, your answer is the 5th generation mobile network. For how is it better than 4G, you're going to say it's faster, smarter, and more powerful. What about its top 3 features? That's high speed, a strong connection, and multi-device support. And for key uses, just think of the cool stuff: AR/VR, self-driving cars, and smart homes. The big idea behind it all? Connecting everything, everywhere. And hey, if you need a super quick way to remember the main advantages during a test, here's a simple memory trick for you. Just remember the letters FSP. 5G is faster, smarter, and powerful. FSP. It's a really easy way to recall the core upgrade. So we've covered what 5G is and what it can do right now, but honestly, the most exciting part is what's coming next. Which brings us to our final thought for the day. With a world where everything is connected almost instantly, what new idea or invention that we haven't even dreamed of yet do you think 5G is going to make possible? The future is really yours to imagine.
Hey everyone, welcome. Today we're going to pull back the curtain on one of the most important parts of the internet, the data packet. These are like the tiny, secret messengers that make literally everything you do online happen. So let's get right into it. So think about this for a second. You snap a photo, you hit send, and bam, your friend who could be halfway across the world sees it almost instantly. How on earth does that actually work? Is it magic?
Well, it's definitely not magic, but it is super, super clever. See, your phone doesn't send that big photo file as one giant piece. Instead, the internet breaks it down into thousands of tiny little chunks. And each one of those chunks has a name. It's called a data packet.
So here's our roadmap for today. We'll start with a really simple way to think about this: the internet's postal service. Then we're going to peek inside one of these digital envelopes. We'll follow a packet on its journey and figure out why we even use them in the first place. And of course, we'll wrap it all up with an exam cheat sheet so you're totally prepared. Okay, first up, let's talk about the best way to imagine what data packets are doing. Just think of it like the internet has its very own postal service. So what is a data packet officially? Well, for your exams, you're going to want to remember this exact definition. A data packet is a small, manageable unit of data transmitted over a network. That's it. It's the basic building block for, well, pretty much everything you do online.
And this postal service idea really helps make it click, right? Just like you'd put a letter inside an envelope and write an address on it, the internet takes a little piece of your data and puts it inside a digital envelope. That's our packet. It's a simple idea, but it's what makes the whole thing go.
Okay, so now that we get the basic idea, let's get a little nosy. Let's rip open one of these digital envelopes and see what's actually inside. You know, on a high level, it's actually pretty straightforward. You can just think of a packet as a little box, and in that box, you've got two main things. You've got the actual stuff you're sending, and you've got the address label that tells it where it needs to go. Now let's get just a little more technical, because you'll need to know this. Every packet really has three main parts: the header, the payload, and the trailer, which sometimes gets called a footer. Let's look at what each of these does. First up is the header. This is the address label, and it's absolutely essential. It has the IP addresses for who's sending it and who's receiving it. Think of those as the unique home addresses for every computer. It also has a sequence number, which is going to be super important later for putting the message back together. Next, you've got the payload. This is the good stuff. This is the actual content, the little piece of the message you're trying to send. If it's a photo, the payload might just be a tiny square of that photo. If it's an email, it could just be one word. It's the whole reason for the journey. And finally, bringing up the rear, you have the trailer. I like to think of this as the quality check. It has a little bit of information that lets the computer on the other end check if the packet arrived safely or if it got messed up along the way. Kind of like a little handle with care sticker. All right, so we know what a packet is, and we know what's inside of it. So now let's follow these little guys on their big adventure across the entire internet. So remember how your photo got broken up into maybe thousands of packets? Well, all of them get sent out into the network. They all travel on their own, and then once they finally get to where they're going, they have to be put back together in the exact right order. It's just like finishing a jigsaw puzzle.
So this is the key takeaway, this three-step journey. First, the data gets shattered into packets. Second, each of those packets finds its own way across the network. And third, they all get pieced back together at the end using those little sequence numbers we talked about.
Now, here's the part that is just so cool. They don't all follow each other in a neat little line. Each packet can take a totally different route. It's like a fleet of cars trying to get to the same place. If one hits a traffic jam, the others can just find a different way around. This is what keeps the internet from getting totally clogged up. Now, you might be thinking, this sounds kind of complicated. Why break everything up just to put it all back together again? Well, there's a really good reason. Actually, there are a few. It all comes down to three huge advantages, and you will definitely want to remember these words for your exam. Using packets makes the internet fast, reliable, and efficient. These three things are the secret sauce that makes streaming movies and video calls even possible. So let's break that down. It's faster because sending thousands of little things is way quicker than trying to shove one massive file down the pipes. It's more reliable because if one tiny packet gets lost, which happens, the system just has to ask for that one tiny piece again, not the whole file. And it's super efficient because the network can juggle packets from thousands of different people all at the same time without anyone getting in anyone else's way. Okay, we have covered a lot. So now let's boil it all down into a super simple cheat sheet so you can walk into your test feeling totally confident. Here it is, your ultimate cheat sheet. So remember, data gets broken into small packets. Each packet has the message part and the address part. They travel across the network and get put back together at the end. And why do we do it? Because it's fast, reliable, and efficient. That is the whole story right there. All right, let's do a quick practice run. A super common question on an exam might be this: what are the two main parts of a data packet and what is their function? Take a second, see if you can answer that. And here's your perfect answer. The header is the address label. Its job is to tell the packet where to go. The payload is the actual data. Its job is to carry the piece of the message being sent. Simple, to the point, and that is a full marks answer. And finally, just to make sure this stuff really sticks in your brain, I've got a little memory trick for you. Just remember the letters PAP. It stands for a piece of data with an address in a packet. PAP. It's really that simple. You've got this. Good luck.
Hello and welcome. Right now, all around you, there are these invisible waves carrying tons of information. They're powering your phone, your music, even the internet itself. So today, we're going to make the invisible visible. Let's dive right into the amazing world of frequency.
I mean, it's a classic modern mystery, isn't it? You're trying to stream a show, or maybe you're in an online class, and someone in the kitchen decides to heat up some leftovers and boom, buffering. Well, stick with me, because by the end of this explainer, you're going to know exactly why that happens.
So here's our game plan. We'll start with the basics of these invisible waves. Then we'll climb up the spectrum from kilohertz all the way to the super busy gigahertz band. We'll even check out super fast 5G, and then we'll wrap it all up with a solid revision session for your exam. Let's get to it.
Okay, first things first. Before we can really explore this hidden world, we need to speak the language. So let's get a few of these basic terms down cold.
Right, so the most important word you need to know is this one, frequency. Just imagine waves at the beach. If you see a whole bunch of waves crashing onto the shore every single second, that's what we call high frequency. But if only a few waves roll in, well, that's low frequency. It's really just a measure of how fast the wave is vibrating. This definition, it's a must-know. Lock it in.
And how do we actually measure the speed? We use a unit called hertz, or you'll usually see it as Hz. It's super simple. One wave cycle happening in 1 second is exactly 1 hertz. This is our fundamental building block for everything else we're about to talk about.
Now, here's where it gets interesting, because we almost never deal with just 1 hertz. Instead, we talk in much bigger numbers. We use kilohertz for thousands, megahertz for millions, and gigahertz for billions of cycles per second. And check out that key relationship up top. As the frequency goes higher, the wavelength, the actual size of the wave, gets shorter. This is an absolutely critical concept for your exams.
All right, with the basics under our belt, let's make our first stop on the spectrum. We're going to see how this all builds up in the kilohertz and megahertz bands. First up, we've got the long-distance champions, AM radio. It operates way down in the kilohertz range, so these waves have a really low frequency, which means they have a very long wavelength. And that special property is what allows them to travel huge distances. It's why sometimes, late at night, you can pick up radio stations from a city that's hundreds of miles away.
Now, let's jump way up the ladder into the megahertz range with FM radio. We just went from kilo to mega. That's 1,000 times leap. This much higher frequency can't travel nearly as far, but it can carry a whole lot more information. And that gives us that crisp, clear sound quality that's just perfect for music.
And this right here perfectly illustrates a core concept you need for your exam. If you get a question asking you to compare AM and FM, this slide is your answer. It's all about a trade-off. Lower frequency gets you longer distance. Higher frequency gets you better quality. Got it? Awesome.
So staying in this megahertz range, we find the ultra-high frequency band, or UHF. Think of this as a busy neighborhood. It's where your digital TV signals live. But look closer. It's also where the RFID technology for stuff like your bus pass or smart cards operates. It just goes to show how different technologies can actually share a very similar space on the spectrum.
Okay, it's time to take another huge leap up the ladder. Welcome to the gigahertz band. You can think of this as a totally packed superhighway, where the devices you use every single day are all trying to merge into the same lane.
So who are the main cars on this highway? Well, it's Wi-Fi and Bluetooth. When you connect your computer to the internet and your wireless earbuds to your phone at the same time, both of those devices are using almost the exact same frequency, right around 2.4 gigahertz. They are literally sharing the same lane, which, can sometimes cause a little digital traffic jam.
So we've got Wi-Fi and Bluetooth zipping along, but they are not alone. There's an unexpected guest hogging this lane, and it's a really common household appliance. Any guesses what it could be?
And here it is, the kitchen surprise. It's the microwave oven. You see, it heats your food using waves at 2.45 gigahertz. And that is the answer to our big mystery. That frequency is smack dab in the middle of the Wi-Fi band. Your microwave isn't perfectly sealed, so it leaks a little bit of that energy, creating noise that interferes with your Wi-Fi signal. So yes, making popcorn can absolutely cause your internet to lag.
All right, so from the kitchen, let's just blast off to the absolute cutting edge of technology. Let's talk about the speed demons of the mobile world, 5G.
Now this is a massive jump. We've gone from 2.4 gigahertz for Wi-Fi to this huge range of 24 all the way up to 100 gigahertz for 5G. This is an extremely high frequency. And remember our rule, right? Higher frequency means a shorter wavelength and a shorter range.
That's why 5G is ridiculously fast, but the signal can get blocked easily by things like walls or even your hand. It's always that trade-off between speed and distance.
Whew, we've covered a lot of ground. So now, let's switch gears and get into full-on revision mode. This is where we make absolutely sure all these key facts are locked in your brain for that test. This slide right here, this is your master study guide. It lays out everything we just talked about in one perfect little table, from AM radio all the way up to 5G with their frequencies and what they're used for. Seriously, my advice, pause right here, take a screenshot of this, and use it to quiz yourself. And to help you practice, here are some really typical exam questions. Can you answer them right now? For example, can you explain that whole microwave interference thing? Or name a few technologies in the megahertz range? Honestly, working through these is the best way to see if you really understand this stuff.
Look, if you remember just one thing from all of this, let it be this simple progression. The spectrum just climbs in order. Kilohertz is at the bottom, then comes megahertz in the middle, and way up at the top is gigahertz. If you can get that order right, you've basically grasped the core of this whole topic.
And if you need a little help remembering that order during a stressful test, here's a simple little memory trick for you. Just think of the first letters, K, M, G. It could stand for kids, then moms, then grandparents. K, M, G. Whatever works for you. A silly trick like that can be a total lifesaver in an exam.
And really, that is what this is all about. You haven't just memorized a bunch of facts for a test. You've actually gained a whole new way of seeing the world. It's like having a superpower to understand the invisible connections that make our modern lives work.
So, I'll leave you with this last thought to chew on. We've gone from kilo to mega to giga. So, what comes next? What kind of amazing new technologies will that next big leap in frequency unlock? Something to think about. Thanks so much for tuning in, and the very best of luck with your revision.
Have you ever stopped to think about what makes your phone, your Wi-Fi, or even your TV actually work? It's all powered by this invisible pulse, this kind of secret language that all our technology speaks. Well, today, we're going to decode that language. We are talking about frequency. I mean, think about it. You're streaming your favorite show, everything's going great, and then buffering. Ugh, the worst. Or you walk into a different room and your Wi-Fi signal just vanishes. We have all been there, right? The reason all that stuff happens is exactly what we're going to get into today. So here's our game plan. We'll start with the basics of the invisible signal, then we'll define what frequency actually is. We'll see why it's so important, learn how it's measured, find it all around us in the real world, and then we'll wrap everything up with a quick review to get you ready for your exam. Let's get started. All right, let's dive right in. First up, we need to understand the thing itself, the invisible signal. Okay, so every single time you send a text message or connect to Wi-Fi, your devices are basically talking to each other. But how? They're using these invisible signals, this special language that just travels through the air. And the most important word in that entire language is frequency. Okay, so what is frequency really? Let's get down to the core definition. You might want to get your notebooks ready for this because this is a classic exam question. Look at this diagram for a second. Imagine that wave you see is a signal traveling for exactly 1 second. Frequency is actually super simple. It's just counting. You're just counting how many times that wave goes up and down in that 1 second. That's it. That is the entire core idea. You know, this is my absolute favorite way to think about it. Imagine frequency as the heartbeat of the signal. A fast heartbeat means more beats every minute, right? Well, it's the exact same idea here. A high frequency just means more of those signal waves per second. Simple, powerful, and really easy to remember for the exam. So here it is, the official textbook definition. You're going to want to write this down. Frequency is how often data signals are sent over a communication channel in 1 second. Seriously, memorize that sentence. It will almost certainly be on your test. Okay, so now we know what frequency is. But why does it matter so much? Why should we care? Let's find out in section 3, the role of frequency. So why does counting these little waves matter? Because, as you can see here, frequency controls the two things we care about the most when it comes to our gadgets: speed and clarity. It really is the master controller. And this slide shows the crucial trade-off. A higher frequency, over on the left, is kind of like a sports car. It's packed with data, which gives you incredible speed and a super clear signal, perfect for streaming HD video. But it runs out of gas pretty quick. It can't travel very far. Now, a lower frequency, on the right, that's more like a long-haul truck.
It's slower, sure, and carries less data, but its superpower is range. It can travel for miles and miles, which is why we use it for things like AM radio.
Now that we understand its role, let's learn how to actually speak the language of frequency. Welcome to Section 4, where we'll check out the Hertz scale. We measure frequency using a special unit called Hertz, which we just shorten to Hz. And 1 Hertz is incredibly simple. It just means 1 signal cycle per second. This diagram is great because it shows how the scale just climbs up like a staircase, getting more and more powerful with each step you take.
So let's climb that staircase together. At the very bottom, we've got kilohertz. That's 1,000 cycles every second. Then we take a huge jump up to megahertz. Now we're talking about 1,000,000 cycles per second. And at the very top, where your Wi-Fi lives, is gigahertz, and that is a mind-boggling 1 billion cycles every single second. Kind of crazy, right? Okay, let's connect all this theory to the real world. In Section 5, we're going to see how frequency is truly all around us. This mind map shows it perfectly. Frequency is everywhere. It's the invisible engine in so many devices you use every single day, probably without even thinking about it. Let's pinpoint a few you definitely know. First up, Wi-Fi and Bluetooth. Both of these operate way up in that high-frequency gigahertz range. Why? Because they need to send a ton of data very, very quickly over a pretty short distance, like inside your house or from your phone to your headphones. That super high frequency is what gives you that fast, smooth performance you expect. Next, your mobile connection. Technologies like 4G and especially 5G use all sorts of high-frequency bands to give you that super fast internet when you're on the go. When you hear about the massive leap in speed from 4G to 5G, a big part of that is because 5G can use even higher frequencies to deliver way more data way faster. And remember that whole trade-off we talked about? Here it is again. Old school radio and TV use much lower frequencies. They don't need blistering speed. What they need is range, the ability to send one signal over huge distances to reach everybody. And it's not just for communication. Your microwave oven uses a very specific frequency that's perfectly tuned to shake the water molecules in your food, which is what actually heats it up. And those security tags in stores? Yep, they use radio frequencies too. It really is everywhere. Okay, let's lock all this in for the exam. In our final section, we are going to boil everything down to a simple, powerful cheat sheet. And here it is, your ultimate cheat sheet for the exam. Seriously. Everything you need to remember is right on this one slide. Let's break it down real quick. 1. The definition. Frequency equals signals per second. Got it? 2. The impact. What does it do? It controls a signal's speed and clarity. 3. The metric. We measure it in hertz, kilo, mega, giga. And 4. The scope. It powers everything from 5G to microwaves. That's it. That is what you need to know.
All right, time to test yourself. Here is a typical exam question. Go ahead and pause here for a second and try to answer it. Define frequency and its unit of measurement. Give 2 real-world examples of technologies that use different frequency ranges. You have everything you need from that cheat sheet we just covered. You can do it.
And one last thing before you go, a little memory trick for the exam. Just remember this phrase, high frequency equals fast and flawless. That's your key to instantly remembering that crucial link between frequency, speed, and clarity. Good luck.
Hey everyone, welcome. Let's take a quick trip back in time, shall we? We're going to see how our phones went from those giant bricks that could only make calls to these super smart devices we literally can't live without today. We're going to break down the evolution of mobile networks all the way from 2G to 5G.
Okay, so you know that little symbol you see at the top of your phone screen every single day? The one that says 4G or maybe even 5G? Ever really stop to think about what that means? Well, that's exactly what we're going to unpack today, because understanding that little letter and number is the key to understanding, well, pretty much everything your phone does.
So first things first, that G, it just stands for generation. Super simple, right? Think of it like chapters in a book. Each new generation is a massive leap forward in technology. And the rule is easy. The bigger the number, the faster and more powerful your connection is.
All right, let's hop in our time machine and rewind the clock. We're starting at the beginning of the digital age for cell phones. Let's talk about 2G.
So picture this, it's 1991 and 2G has just arrived. Now the biggest change here was that we went from analog to digital signals. All that really means is that calls got way clearer and more secure. But it also opened the door for something completely new.
And that new thing?
It was SMS. You and I just call it texting. This was the absolute game changer for 2G. Before this, phones were just for talking. Suddenly, you could send a written message to someone. I know it sounds so basic now, but back then, it was totally revolutionary. Now, for your exams, this is key. 2G equals texting. Simple.
Okay, so we can talk, and now we can text. What's the next logical step? Well, getting online, of course. This is where 3G comes in and puts the internet right in the palm of our hands.
So just a few years later, around 1998, 3G shows up, and it changed everything all over again. See, if 2G was about adding text to our calls, 3G was all about adding the internet. The web wasn't trapped on your big desktop computer anymore. Nope, it was officially in your pocket.
So, the number one thing to remember for 3G is internet access. The speeds were finally fast enough that you could actually browse a basic website or check your email on your phone. For the first time ever, you could be on the bus and look up your notes for school. That was the magic of 3G.
All right, now we're getting into the territory that most of us are really familiar with. A generation that was defined by one thing above all else: pure speed. Welcome to the era of 4G.
Launching around 2008, 4G wasn't just a little step up from 3G. Oh no, it was a giant leap. The jump in speed was kind of like going from riding a bicycle to driving a sports car. And that speed didn't just make browsing faster, it made totally new things possible.
You see, 4G gave us what's called mobile broadband. But what does that really mean? Well, for us, it meant one thing: video. Suddenly, smooth, high-quality video streaming was a reality. Think about it. YouTube, Netflix, video calls, scrolling through your social media feed, all of that is built on the back of 4G speed. It completely changed entertainment and even how we learn.
So, if we have high-speed video, what could possibly be next? Well, the answer isn't just about making our phones even faster. It's about making everything around us faster and smarter. Let's get into 5G.
Starting around 2020, 5G began rolling out. And yeah, it is ridiculously fast. Like, download a full movie in a few seconds fast. But the real mission of 5G is so much bigger. It's built to handle a crazy number of connections all at once, creating this huge connected ecosystem. So the big idea for 5G is the ecosystem. It's not a network just for your phone anymore. It's designed to connect your TV, your watch, your smart lights at home, maybe even your car, all running at the same time without ever slowing down. It's really the foundation for all the cool tech of the future.
Okay, we've made it through the whole journey. Now let's totally switch gears. It's time to get laser focused on what you need to nail for your exams, so pay really close attention to these next few slides.
And I'm not kidding here. If you've been taking notes, this is the part you want to put a big star next to. We're going to boil everything down into simple, easy-to-remember points just for your tests. You ready? Let's do it. Okay, this chart right here just lays it all out perfectly. Just look at how it shows you the year, the kind of phone, and the main feature for each generation, all side by side. You've got 2G in '91 bringing us texting, then 3G in '98 with the internet, 4G in 2008 for video, and 5G around 2020 connecting everything else. And you see that note at the bottom? It's telling you, review this for the test.
Here's another way to lock it in. Think of it as a simple four-step story. In 1991, we just got basic communication, voice and text. Then in 1998, we got information with the web. By 2008, it was all about entertainment thanks to video. And now, since 2020, it's about integration, connecting our entire smart life.
Seriously, if you only remember 4 things from this whole explainer, make it these 4. I'll say them with you. 2G, texting. 3G, internet. 4G, video. And 5G, connecting everything. That is the core of this whole topic right there.
And to make it even easier, I've got a super simple memory trick for you. Just remember the word TIV. That's T-I-V-E. It stands for texting, internet, video, and everything. TIV. It's a perfect way to remember the main feature of each generation, right in order.
So, as you can see, this whole evolution is about so much more than just our phones getting better. Each one of these steps, especially this huge leap to 5G, is fundamentally changing the way we live, the way we learn, how we travel, basically every part of our lives.
And that brings us right to the end. We've seen how each generation built on the last one, from sending a simple text message to building a totally connected world. So, I'll leave you with this one last thought. If 5G is here to connect everything, what in the world do you think 6G is going to do?